Welcome to qnawire.
Hi, in the given problem, this is the circular loop of a conducting wire, and there is a magnetic field coming out of the plane of paper, and this is linked through this coil also, like this. The radius of this coil has been given as 0.0480 meter. The resistance of the coil is 0.160 ohm, and the magnetic field is coming outward, and this magnetic field is reducing with the time at the given rate as minus 0.680 Tesla per second, and the initial magnetic field linked with the coil is B0 is equal to 8.00 Tesla. In the first part of the problem, we have to find the direction of current induced in this coil as a result of change of magnetic field. As the magnetic field is outward and it is decreasing, so the reason behind the EMF induced will be outward decreasing magnetic flux. So as per Lenz's law, the induced magnetic field should be in a direction which may oppose this outward decreasing magnetic flux. So the induced magnetic flux will be outward but increasing. As the magnetic flux, induced magnetic flux is outward increasing, so this face, the upper face of the coil, should start behaving like north pole, or we can say the direction of current induced in this should be counterclockwise. Here this is the direction of the current induced, which is counterclockwise, and this is the answer for the first part of the problem. Now in the second part of the problem, we have to find the rate at which electrical energy is being dissipated by the resistance of the loop. So for this purpose, first of all, we will find the expression, the value, the magnitude of EMF induced, and that is given by Faraday's laws of electromagnetic induction, as EMF induced is minus d phi by dt, or we can say this is the differentiation of B times A, where A is the area and B is the magnetic field with respect to time, or it will become, as the area is constant, so this is minus A dB by dt. So we put these values here. This is pi r square, and we know the radius is 0.048 to the whole square, and for dB by dt we know this is minus 0.680. So finally this EMF induced comes out to be 4.94 into 10 raised to the power minus 3 volt. This is the magnitude of the EMF induced in this coil. Now finally we have to find the rate at which the electrical energy is being dissipated, for which we will use the formula for the power as EMF is square divided by the resistance, and it comes out to be 4.94 multiplied by 10 raised to the power minus 3 to the whole square divided by resistance, which was 0.160, and finally this power comes out to be 1.52 multiplied by 10 raised to the power minus 4 watt, and this is the answer for the second part of the problem. Thank you.